Hey,
Hey,
hi. Hi, everyone. And yeah, good evening, friends. Yeah, watch this. That's a good number. Wonderful. All right, friends, let's begin the session. Let me share my screen. All right, let me just check on this. How about now? Are you able to hear me now? Okay, you're able to hear me now. Okay. Not sure what happened. Initially, when we started, it was clear. In fact, I checked, but I think later on some internet issue creeped in. All right. So let me let me restart. Okay. I think you guys did not get anything. Sure. Let me revise from the scratch. We'll talk about this. No problem. Okay. Let's start. Let's start. Yeah, I'll be checking your messages in another system. Okay, I'm asking my colleague to check. So if you have any issues, just put messages. I'll in between keep checking. Sure. All right. So let us restart. Okay. Let me restart. All right. So once again, welcome to all. And as part of today's webinar, we are talking about the specific tool called Apache Flume. Apache Flume is a tool which is basically used to ingest data. So as part of this webinar series that I have taken up, I am focusing on discussing about how you get data into your system, big data platforms. There are various ways. We will be trying to cover a few of those things. We discussed about big data platform. We discussed about file formats. We discussed about data ingestion concepts. And we tried to compare multiple tools. And as part of our previous sessions, I also covered a concept called as Sqoop, Apache Sqoop. This Apache Sqoop is used to load the structured data or import, export. I should say import and export the data from RDBMS to HDFS. HDFS is your big data platform, right? So we are going to do import and export using Sqoop. So this is SQL based. And when I say HDFS, this is Hadoop. So here I'm taking SQ and here you're taking OOP. So this is the combination and this is your Sqoop too. But remember, it is only working with structured data. Okay. So what is ingestion? What is data ingestion? To start with, data ingestion is a concept wherein it helps us get the data into the system, into your big data system. Because the data could be generated from sources and you could be storing it into some softwares, right? And if it becomes too big, you'll not be able to process this data here, right? So you want to bring in this data into this specific platform. You're ingesting the data, right? So that process is called as data ingestion. Now, if you observe the scenario here, when we talk about this data ingestion concepts, you need to understand that the businesses are generating data and they're recording the data into their specific systems. Okay, I was basically talking about one example, Amazon, wherein Amazon as an application, as a platform, it allows people to do business. Now let's say Amazon wants to do some recommendations. It wants to do some recommendations. How does it do that recommendation? It needs to basically study the user first, right? Only then it will be able to do the recommendation. But if you want to study the user, you need the data. And you are going to do the recommendation on the live. You're not going to send an offline message to a user, right? When he's not logged into the system, isn't it? So we need this live data. So Amazon is capturing that live data in the form of logs. It's a server application, right? So how many people are logging in, what are their user IDs, when did they log in, what transaction they did, when did they log out. All this information would be present in the log data, or you also call it as event data. Twitter example, your Twitter is continuously getting data, right? So that continuous data that we are seeing has to be captured. Now this data, which is generated by various business sources, could be in either structured or unstructured form, right? Now, if the data is in structured format, then there is no problem because there are traditional tools which are used for handling that data. Your databases, RDBMS databases, SQL-based databases, SQL-based databases. These are traditional systems, right? From ages, businesses are using these softwares. So handling structured data, no problem. But getting this data for performing analytics, for that you need data ingestion tool, some tool which can pull the data into big data system. And that's what we discussed in the last session, in the previous sessions. Sqoop, which is basically a tool which helps us to import and export data between RDBMS system and big data platform, Hadoop. But when it comes to unstructured data, your traditional systems are not designed in the first place to handle this unstructured data, like Amazon logs, right? They cannot store all the data. So we need in the first place a specialized tool to store this data and handle this data. And those tools, generally we call them as NoSQL databases or NoSQL systems, or your big data platforms which can handle this unstructured data, right? And processing this unstructured data is another big challenge. And you need specialized tools, right? On big data platforms, you need to have the specialized tools to process that unstructured data. That means I need to get that data onto my big data platform, right? So collecting, storing, aggregating, and dumping that data into a persistent storage system. This is the job of a specialized tool, and Flume fits that bill. Flume, Apache Flume, we call it as Apache Flume, that is, it's open source, remember that. And this open source tool basically collects the data which is in unstructured format. It is used to stream the data. When I say stream, we are talking about live data. So this, if you look into this example, I have cloud-based instances, I have Facebook social media, I could also have servers, client servers. All these are the different sources where your live data is getting generated, right? And this data is generally unstructured. So we are storing this live log or event data through Apache Flume. We collect using this agent, we call it as Flume agents, and those Flume agents aggregate the data and push that into your distributed environment. This is your assume Hadoop cluster. So here you can directly dump on HDFS, or you can also use HBase, which is a distributed database on top of HDFS to store the data. This is basically the requirement, or this is basically the job of Apache Flume. So remember, it is used to work on unstructured data. As I said, Flume is an open source framework. It ingests log data or event data, right, from multiple different sources into this centralized storage device, right? It also has command line interface to write the programs at a high level to ingest the data. The transactions that we are seeing in Flume, right? These transactions basically are, I should say, have reliable sources. I mean, they monitor, they clearly monitor the data, the transaction that is happening in these two channels. It keeps this details. The detail, basically, the transaction details that it maintains is basically one for the service, the generator, that is the data sender, the source, and it also has the information on the receiver. Where does it is? Where did where do it get stored? So it is basically it is basically having the information about source and destination, receiver and your sender. All right. Now, if you have this kind of a proper data maintained, right, then using this information, we can basically, right, guarantee the message delivery. You will be able to say that, okay, well, let's monitor it and see whether the data is getting, right, reached to the destination or not. So that's basically what your Flume does, right? Now it basically has these options. It is basically is reliable, fault tolerant, scalable. It can be customized. It can be managed. These are all additional features which your Flume provides you, right? See, Flume also has this advantage. It is very, very reliable, and it basically handles a huge rush of the data also. Now you might have Amazon. I'm talking about Amazon, right? Suddenly there is, let's say Amazon is doing the business and suddenly there is an offer. In fact, I think Amazon has some offer in India, right? In the first week of August, the independent sale offer or something, the Great Indian Sale, something they call it. So on that particular day, for example, there could be a huge rush. Millions of people might log in. So the data that is getting generated, right, is so huge, which your Apache Flume may not be able to handle, right? So the incoming data that we are having might increase a lot, multiply, right? Now Flume will be basically acting as an agent, soothing agent, right? Which helps to streamline the flow of this data into HDFS, because HDFS is a batch mode system. So the huge rush of data that is getting generated here at the rate at which this data is getting generated could be very fast when you're looking at Hadoop systems capability to store the data. So this agent basically is coming in between, which helps this receiver to focus on recording the data, whereas this agent is basically working as a collector, right? And it's slowly, right, passing the data so that none of the data points are missed, none of the logs are missed, and all the data is getting stored into this. So the huge surplus amount of data that is getting generated can also be handled thanks to Apache Flume. Right? It is acting like a bridge between the source and destination, and it is basically maintaining the steady flow for the receiver to store the data. Right? And it is basically channel based. When I say channel based, it basically looks into a process, or I should say a proper flow. Channel means what? It flows, right? So this is one channel. So it makes sure the data, the source that is generating the data is recorded here. Once it is successfully recorded, it will create, I mean, you'll get another channel. So it is channel based and it contains those details I'm talking about here. Receiver and sender. This is the receiver and this is the sender. And only when this data is passed here, the channel can be closed off. Right? You can imagine from that perspective. Now, your Apache Flume has these multiple components. We also have something called as event. Then we have agent. Event is nothing but data. Agent is basically your Flume software, which further has these three components: source, channel, and sink. Using all this, we are streamlining the data to source, from source to destination. And you have to remember again, friends, I'm talking about log data, which would generally be in unstructured format. It deals with unstructured data. So let us look into that concepts. Event is nothing but the data. The smallest unit, basic unit, which is the data, right? One data point which is getting stored, transported from source to destination. From source to, let's say, destination. One basic unit which is getting passed is called as an event. And that event is handled by agent. An agent basically is an independent service, Java based, of course. Now, most of these devices that we are talking about they're Java based. So we have a background process, Java background process, which runs on virtual machine, Java virtual machine for execution. Right? One agent is basically one service, one process. Right? And we might have multiple agents. Not just one agent, but we might have multiple agents. And in each agent, we have three major components or three components. Right? These three components are source, channel, and sink. Source basically means this is the component of agent which collects the data. So here, if I have to draw, the log that is getting generated is going to source. Source is the component which receives the data and then it transfers it to one or more channels. Right? It is basically taking this data, whatever the log that you're sending from or generating, that data is getting converted into event here. And then it is passed to channel. We call it as channel, right? So that's the job of source. Yeah. Now, once the data is there with the source, right? I should say, yeah, this source can generate multiple events also. Okay. And these sources, these events that are getting generated are passed to channel. And here you have multiple channels also. It doesn't mean that you have only one channel. I'm representing as one channel, but it could have multiple channels. One event, one channel. Like that, you might have multiple events, and each event can further be sent, right, handled using multiple channels. Okay? Or you can say, imagine I'm sending one message. Okay, in Twitter, I'm sending one message. I'm generating one message. That one message, you can interpret it as an event, right? The data has to be passed to source. Here we are saying that is one event, and that one event is sent or passed to channel. Now this channel is transmitting. It's a temporary storage location or a temporary, right, area which receives the data from source or event from source, and it buffers. It stores them. It keeps in the channel until the sink is basically taking that data. So it is like a you should say a temporary storage, resting area. So source is sending your events. Here it is getting accumulated unless your sink, which is the last component of your agent, is consuming that data. Right? It's basically a bridge between source and sink. Now sync delivers the events from the channels to destinations. Sync is like it is taking and passing it to the destination. This destination is nothing but your HBase or HDFS, a centralized location. So your sync is storing the data onto your devices, right? Or you can have multiple agents. That's also something that we can talk about. So sync can directly store it into the storage devices, or it can pass to another agent. Now, because of this, right, we need to understand the data flow concepts. Here we have multiple data flows. Okay, for Apache Flume, the data flow can happen in multiple ways. Those multiple ways, right, is what we're talking about now. So the data in the agents, right, will be collected by an intermediate node called as collector. Okay, we have something called as collector also, which is basically storing this information, right? It's just like an agent. I mean, it's just like an agent. We call it as a collector, right? Now, this collector is passing the information. See, there are something called as interceptors, channel selectors, sync processors. All these are different components that come into picture. Okay. So collectors basically are like your intermediate nodes. These are like systems where you temporarily put the data. Okay. And you can have multiple these temporary storage nodes. And what is happening is from these collectors or channels, the data is pushed to the destination, which is your HBase or HDFS, as or I should say via sync. So imagine that this is your channel. Inside the channel, we have something called as temporary node or temporary location where you are storing the data. So here you will have source, here you have collectors, then you will have sync. And from the sync, it would be HBase or HDFS. Okay. So these are three different ways the data can basically be pushed in. See, Flume is basically just a tool, right? Open source tool, which is moving the data from the source to destination. It acts as a bridge between the source and destination. Within that Flume, the data is passed through these multiple subcomponents of Flume. Right? We have Flume agent basically, and you have multiple agents. And these agents are passing the data by collecting from the source, then temporarily storing that, and then pushing it to the source. That's all it does. But when you're looking at the data flow can happen in three different types, in these three different forms. This is the first one. We call it as multi-hop flow. We can have multi-hop flow or fan out flow or fan in flow. Multi-hop basically means the data is hopping between multiple agents within Flume. We have multiple agents, right? So let's say this is the source. Here you have agent, Flume agent, and this is your destination. So your data may be hopping between agents before it goes to destination from source. Or you can also have one agent, okay, that is also possible. So if it is hopping between multiple agents before it is going to the final destination location, this process of flow is called as multi-hop flow. That's multi-hop. Then we have something called as fan out flow, right? Fan out means you will have multiple channels. We don't have one channel, we have multiple channels. In agent, we can have multiple channels. So you basically have one source, right? And here you have agent. And in the agent, we have source, right? We have source like what we have seen in the previous image. If you see here, you have source, channel, and sink, right? So the data is coming to source. From source, it might go to multiple channels. That's called as fan out. The data flow from one source may go to multiple channels. And then we also have something called as replicating and multiplexing. These are subtypes in your uh, what do you call it, the fan out option. Then we also have something called as fan inflow. So your channel that we are talking about here can read the data from multiple sources. So if I take this as one source, this as one source, right? All this data can go to a single channel. This is your source. And this is multiple sources within one agent. This is called as fan in, because channel is basically aggregating. It is buffering the data, storing the data temporarily, and buffering the data, right? And aggregating the data, collecting. And then it pushes to the destination via sink. So fan out basically means from one source to multiple channels. Fan in means from multiple sources to one channel. Multi-hop means one agent to another agent. Within agent, you might have multiple channels or multiple sources. So this is basically your three types of data flows that we have in Apache Flume. Right. And when we talk about the disadvantages and advantages of Apache Flume, Flume is a distributed application. Okay, this is the definition. It's a distributed application to collect, aggregate, and load streaming data. Right? And Kafka is used along with Flume generally to make sure that we also improve the reliability further for Flume. We'll in next classes, in future classes, we'll also talk about what is Apache Kafka, which is basically a messaging, right, streaming messaging system, distributed messaging system rather, and it has a bunch of advantages to itself. So we'll discuss about that in the next class. But these two together can also work to improve the source data's reliability. And Flume is especially used for handling unstructured or semi-structured sources or data. For structured data, we do not use Flume. You have various other tools, right? And especially it deals with live streaming data. And as I discussed, it has capacity to handle huge amount of inflow. We call it as the rate of data generation, right? Rate of data generation is very, very, very high compared to the rate at which the data is consumed. The rate at which the data is stored. Even in this case, Flume works as a buffering agent or a temporary storage device wherein all this data is getting accumulated here. And then the data is passed to the destination, and destination can work at its own speed. So that's the advantage of Apache Flume. It has recoverability. You can recover the lost data and lower latencies. It doesn't take much time to work with Flume. And it supports wide variety of sources, data sources. It has fault tolerance because it maintains the transactional details, right? It knows whether the data is received or not. And if by any chance, if sync fails from source, again, you create a channel and send the data to the destination, right? So you'll not lose the data basically. and it can handle huge amounts of data. There's no problem with the size. It guarantees the data. Okay, we guarantee the data reach, but the order at which the data is getting generated, that is the problem with Flume. It does not record the order. Say, for example, the first event, right, is user login. So this particular login details are basically shared to a source agent. And from here, it is going to a channel. And let's say your destination is busy. So channel is not directly sending it to sync for consumption. So it is temporarily holding it here. But this events would not stop, right? So second event has started. Some transaction is being done by the user. So you again send it to source, a new source, and you'll get a channel. Now I know source and I will know destination. So it will wait till the data is getting stored. But this data might get stored first. So that ordering of the data is not guaranteed. That's one of the disadvantages of Apache Flume. And duplicacy, you're right. If channel is broken down, then you again recreate another channel. By that time, probably sync is already storing the data. So duplicate information can come. It doesn't check for the duplicacy. Scalability is low. You cannot have too many channels, too many syncs. It cannot work at a higher, larger scale. And topology, it's really complex. You have too many connectors, channels. You have, the sources to channels, one channel to multiple sources to one channel. So this complexity is there, and the software is very large. It's too complex software. And though we say it is reliable, still we have reliability issues. And because of that, we also use Kafka. Because the ordering is not correct, right? So reliability still is a challenge with Apache Flume. And if you compare Flume with Sqoop, Sqoop is import-export option. That means export is also there. Whereas here it is only import. Sqoop works with structured data and Flume works with unstructured and semi-structured data. It's a connector based. You connect, establish a connection, and then push the data. Whereas this one is agent based. Agent means you'll have a dedicated agent there sitting, and you talk to the agent and then push the data. And this is worked with offline data, whereas this is worked with online data or live data. Event driven, that means when an event is created, only then Flume comes into the picture. Only then the data has to move, right? Whereas for Sqoop, there is nothing like event because it's working offline. You execute the command whenever you wish, right? You want to pass the data, which is already there, stored. Then you decide. You want to do it today, tomorrow, after 1 hour, or after 1 week, you decide that. Whereas in Flume, when the data is getting generated, that's exact time the agent is initiated. Kickstart. Sqoop, the destination could be your HDFS, from SQL to HDFS, or from HDFS to SQL. That's how Sqoop works. Whereas a Flume can consume the data from various channels, various sources. Right? Here you'll have SQL only. Again, within SQL, you'll have different softwares though, but ultimately it would be only structured data, right? Not different types of data. Whereas here you can basically load the data from different channels. That means different sources can give you the data. So that's a comparison between Sqoop and Flume. So that's basically what I have today. And that's all I have. Hands-on, considering the time aspects, I would not be able to show you the hands-on. Probably in the next future sessions, we will do the hands-on as well. And see how we can pass the data from any server which is constantly generating data. It's very easy, don't worry. I'll be explaining you that. You basically have to write some bunch of commands, and it is going to push the data into your HDFS. Right. So let me see your questions now. If agent doesn't respond, the channel, will it transfer to the agent? Doesn't mean that there's no point of agent doesn't responding. You'll have multiple agents, right? And agents are triggered when the data is getting generated. And within the agent, you have channels. Yep, Harshvardhan. Okay, what does that 6th and 7th means? I didn't get that. Mayuri, the entire session that is happening will be there on YouTube. In fact, it is now happening live on YouTube as well. Okay. You're talking about the offer date. Yeah. Okay, Harshvardhan. Now I get it. Yeah. All right. So yeah, that's it. We will conclude the session for the day now, and we'll connect again in the next webinar, friends. Do subscribe to the YouTube channel to get the latest updates on the webinars that we are doing. Not just in the space of big data, we do conduct the webinars on various different topics. So yeah, might want to register and make sure you are getting the advantage of that YouTube channel live videos. Okay, see, Tableau is there, ML on Cloud DevOps, right? AI related concepts will be discussed. So a lot of things are being done here. If you have not registered yet, please do that. All right. So thank you, friends. With that, right, let's conclude, and good night. Okay, I have a question. What amount of data the Flume can buffer in case of receiver? As much as possible, Muthu. You can basically configure that. Wonderful, Harshvardhan. Yeah. So you attended the AI and deep learning concepts, is that session? Great. Now, when you say I am proud, we feel very proud that our customers, you people, are taking that pride. Yeah. So thank you for such a wonderful comment. All right, friends. Thank you so much, and keep learning, keep upskilling, and every day is a learning, right? So with that motto, let's conclude the session. Thank you, and see you in the next webinar.